So as we go into some reviewing here, our form, what is slope-intercept form? All right, and I'm hearing it, y equals mx plus b. Now when we look at the characteristics, what are the important things about this? Well, notice what m tells me. M tells me the slope. In other words, how to move from one point to the next on a graph. And b tells me where to begin, and we call that the y-intercept. So those are the characteristics. And this is probably the most common way to graph a linear equation. The most common. It's also the most common form of how we write it. Next, over here, we have standard form. So please tell your neighbor, what is standard form? Go. Good. So here is standard form. And a key thing to note is, generally speaking, these are integers. Generally speaking, these are integers. They don't always have to be. In fact, oftentimes the instructions will say, rewrite in standard form with integer coefficients. However, generally we already do that. And one other thing about A is usually A is positive. Again, it doesn't have to be, but usually that's positive. Now, what is nice about this, what's one characteristic about this, is that it helps us to find the intercepts easily. So, easy to find intercepts. So this one, easy to find intercepts. So by tomorrow, yesterday we practiced finding intercepts with this. Today we're going to, and tomorrow we'll practice doing that again, but also graphing using those. So instead of looking for directions from one point to another, we're just going to find the two points. Here's one intercept, here's the other intercept, and then we just drop the line on top of it, like that. So slope-intercept form is a very excellent way to graph. This is a good way of graphing. Standard form helps us find the intercepts pretty quickly. So looking down here as we get ready, a contractor needs to build two straight roads, each passing through point A. So here's point A over here at 30, 40. One road must be parallel to Pine Street. In Southern California, most of the streets are perpendicular and parallel to each other, so it makes sense here. So we need to find, essentially, we need to find this street here that goes along there, and we want to find this street here that goes along this. And for whatever reason, it's got to pass through this point. So maybe there is already a gas station being built, or more importantly, a Dunkin' Donuts is being built right there. So they're going to put a street here and a street here, so you have quick access to Dunkin' Donuts or Starbucks. Find the coordinates of a second point of the parallel road that'll pass through. So we want to find another point up this way. And the coordinates of a third point, the perpendicular. So really, it's not overly complicated, because if we approximate a point here, and if we approximate a point here, that will give us the approximate points. Now, right now we're eyeballing it just to see where those points are. However, today we're going to look at, and tomorrow, the skills that will help us to get this straight out. We're going to look at another form, and this will be our last form, called point-slope form. Now, just to confuse you, the two pieces of information that it gives you are the point and a slope. So this is how we write it. It looks like this. Y minus y1, and we actually don't need the parentheses there, equals m, now we have parentheses, x minus x1. And the key thing here is that x1, y1 is a specific point. It doesn't matter what point it is. It could be 2, 5, or 3, -2, whatever. And of course, we recollect what m is. M is the same most of the in all these equations. M is my slope. Hence its name. It's called point-slope form. Because given a point, you just plug it here and here, and the slope, you plug it here. Now you have an equation. In other words, it is a line that has this slope passing through this point. A line that has this slope passing through this point. Notice that we already know about that, because if I did this, and you don't have to write this down, this is saying the exact same thing, but with a particular point. This point happens to be 0 something, right? 0 something. So this also is a point and a slope. It tells you one specific point on the y-axis and a specific slope. And point-slope form tells you the same thing, but the point can be anywhere. The point doesn't have to be on an axis. So this says the point, the m, just like this does, and any point at all. All right, and this one is helpful to graph. And then learn to spell. It's helpful when graphing because we know where to begin and how to move. It's especially helpful when we have 2 points and we want to go to an equation. If we have 2 points and we want to know what the equation is. Look at our first example on page 2. We're going to write the equation of the line passing through this point, negative 5, 2, and has a slope of 3, 5. Well, the nice thing about this is all we have to do is, since I have a point and since I have a slope, I can start with point-slope form. And all I have to do is substitute things in. Notice that this right here, the negative 5, is my particular point. That's my x1. And the 2 is my y1. And lastly, my slope is 3/5, and all we do is substitute in. All right, so like I said, all we do is substitute in. The negative 5 goes here, and notice the double negative makes it into a plus 5. The 2 goes here, so I still have a minus 2. Positive 3/5 go there, so I'm left with this. And this here is my answer. Write the equation in this form. Now, we could write it in another form if it asks you to. It might say put it into slope-intercept form, which means we would have to distribute here and get y by itself. But right now, if it just says write the equation, then you're done. Notice what I'm simplifying here. I'm just making sure the double negative is positive, but I don't have to distribute anything. I don't have to isolate y. I just leave it in this form. All right, the next major skill we want to have is, what if we are given 2 points? Now, the 2 points things are pretty easy to graph. You do not have to graph this. I'm just showing you real quick approximately where it is. So 5, 8 is somewhere about here. And then 3, 2 is somewhere about here. So if I were asked to graph it, then clearly it would be this here. But we're not asked to graph it. We're asked to find the equation that's associated with this. Now, well, as I approach this, I need 2 pieces of information. Remember, if I use point-slope form, so this is how I abbreviate point-slope form, I need 2 things. I need a point and I need a slope. Do I have a point? Yes, not only have a point, I have 2 points, so I have choices. Do I have a slope? Not yet. Like the previous problem gave me a slope, but fortunately for me, I can find slope. Remember how we can find slope? Is simply we can subtract the x's and subtract the y's and make it into a fraction. So step number 1, find slope. So I'm going to plug in. Remember, whichever direction you start from, that's where you go. So for example here, 8 minus 2, if I put that in the numerator, then I'm going to put 5 minus 3 in the denominator. Always go in the same direction. When I finish this up, I get 6 divided by 2, and that simplifies to 3. So step number 1, find slope. Step number 2, choose a point. Choose a point. Pick a point. It never ever matters which point you choose. So how do you know which one to choose? I tend to stay away from the negatives. So in this case, it doesn't matter. Or a lot of people just choose the first thing that's there. So that means you could get what looks like a different answer than your partner. If you choose this one and you choose this one, your initial equation is going to look different. So in this case, I'm just going to choose 3, 2. I will show the alternate option there just to see what happens. All right. And then lastly, we're going to substitute in. We're going to sub it into the point slope form. Why are we choosing point slope? Because we have a point and we found the slope. So again, that is y minus y1 equals m times x minus x1, and simplify that. So y minus 2 equals 3 times x minus 3. There's nothing to reduce there. There's nothing to simplify, and I'm done.